Guys, can you see my screen?
Yes, sir, we can, sir.
Okay, thank you very much. Let us start our class. Um, so, in the morning, I introduced the modeling of a translational mechanical system, and we did together the 1 degree of freedom, and we got to solve this problem. Now we are going to do the one with 2 degrees of freedom. Then we will see if time rise. I'm going already to introduce some tutorials, and I will do some others. I think I will see maybe Wednesday or Monday just to prepare yourself. I think Monday will be better. So maybe Wednesday I will conclude with mechanical, electromechanical. Then we'll take from there. Okay. So as I was telling you that we're doing at first the 1 degree, but here we have a 2 degrees. So there's no that too much difference between the two because the principle is still the same. It first of all to create you need to create your free body diagram for the first one and for the second mass. So you create the two free body mass diagram, free body diagram. So after you create them, you can determine your forces and you can write the equation for the first mass and for the second one. After you wrote these two, then you can be able now to to find your problem. So let's solve this problem. It's written a mechanical system is given below where the input is the mechanical force Ft applied to the mass M2 and the output are the displacement x1 of T of mass M1 and displacement x2 of T of mass M2. Draw the free body diagram, that's the first question. Write the dynamic equation in S domain. Write the transfer function G, which will X. So they ask us to consider X1 of S as the output, as we know that F of S is the input. So this is what we are going to solve right now. Let's go and start solving our problem. Let me go here. See what's gonna have here. Let's just see. Give it a time. Okay. So we can go now to whiteboards. If you can see this problem, we have already the values given to us, that they give the value of M, the value of K1, K2. So we can just using the numerical value to solve. So this make it a little bit easy to simplify. But I'm going to go step by step so we can be all able to solve it easily. Okay, let's see if the whiteboard is ready. Okay, the whiteboard is ready. Can do this. Okay. Okay, so let's now solve this one. So we have this problem with two body. Let's solve first for this mass. For mass number one, we can get the free body diagram for mass number one, and this is gonna be. So we have this, we have this, we have. This is mass number one, M1. So let's go back. How many forces do I have on mass number one? You can count this one for K1, this one for K2, and this 3 for FV. So we have three forces on this one, and all the three forces, this one is if we take in account the motion direction, this is a -1, this one also is a -1, and this one also -1. So we have three negative forces acting on the mass. So we can draw them. So this is a negative force. This one also is a negative force. And we have one acting on this side, the negative force. Okay. So now we need to write the equation of these three forces. Let's go back. When we take this one is a spring. We already know how to write the force of the spring. First of all, I want to write them just using K1, K2. We will replace the value later. So let's now see. So this is the motion direction, which is there. It's x1 of t. Okay. Then we have K1. So this one gonna be K1 times x1 of t. This is the first force. Because it's negative, we can put negative sign. It's minus. And this one also, the second one will be, now listen to this one, we will have K2, let me open the big bracket, times x1 of t. So now if you see this spring here is in between the two masses. So it means that all the there is the force of this one also that's acting on this one, and the force of this one. So it's in between two forces. As we are considering these masses, we need to subtract the force that's coming from the displacement x of 2. So remember, it's almost the same thing as what we're doing when we're doing two loops. So when we consider like the first loop, we subtract all the voltage or currents coming from the second loop, but we don't ignore them. So this force here will be the force coming from this displacement minus this force here. So because we are only considering these sides, we're gonna do the same thing when we'll be considering the other side. So this now will be minus x2 of t. Then we can put the bracket. So we know that this force here is coming. This one is the force coming from this side. So the displacement times the spring coefficient. Okay, all of them are negative. Okay, no, let me just remove this sign. I'm gonna put the sign on the equation. So, and this force K2 times this one is this force, the other force for the second mass that we are deducted. We are subtracting. So same thing for this FV. So we'll have FV, open the bracket. So this is gonna give us now X. This is going to be X1. Sorry, is there any question? Sorry?
I'm having a problem with
Yes,
can you please go back to K2, sir? I'm having trying to understand, sir.
Okay, yeah, I can hear your network is not good. I said this.
Sir, can you please go back to
this one?
Explain K? I'm having a problem with network.
Okay, it's okay. I can hear even the way you are speaking. I said this. We have
Yes,
this.
sir. Can you please explain again K2, sir?
Yeah. We have this mass here. We are only considering the force that are acting on this mass. Okay. So this is the force that we are considering. So because we are considering this one, we have this force. This is acting only on these masses. But when we take this spring here, there is not only the force that's coming from x1, there is also the force that are coming from the displacement x2. So, but what we need here is only the force coming from x1. But in the spring, we cannot consider only one force. So, because we are drawing the free body diagram with this one, we must consider all the forces acting on the spring, but we subtract the force that are not concerned by this particular mass. Are we together? Can you hear me?
Together.
Can you hear me?
Yes, sir. I can hear you, sir.
Okay. So that's what I say. Now there is the force that is K2 times x1 and the force K2 times x2. But we don't need this force in this particular case. So we need to subtract that force from the equation that we are using for this force. Are we together now?
Yes, we are still together, sir.
Yeah, and this force is going even in opposite direction. That we're gonna do minus this one. So this is what I did here. This is what I did here. So I consider this force here, and I say x1 of t minus x2 of t. Same thing for the viscous damper. So I take the force this because this FVS times. Oh, sorry. This one is not well written. Let me write it properly. Okay. So it's gonna be easy for us to understand now. It's d, because we are in the viscous damper, d x1 of t over dt minus g x2 of t over dt. Okay. Okay. So this is the force that are acting on this side. So now from here, we can be able to write our equation. So let's now write the same free body mass diagram. We can write the free body here on the using the impedance law as we did before. Just to simplify things, so we cannot go again to do the Laplace transform. So we can take this the mass one. So we'll have this force acting this side, the negative one. This one also negative one. This also now opposite direction. Okay. So the free body, this one gonna be K1 times x1 of S. And on the other side here, let's move a little bit like this. On the other side, we're gonna have K2, open the brackets, x1s minus x2s. We can close the brackets, and this one gonna be S FV open x1 S minus x2 S. Okay, so we can close also this one. So we have our three forces acting on this mass number one. So we can write the equation. we can write them already in Laplace domain because we have already write it in the free body mass in the free body diagram. So let's now write the forces we will have minus K1. Let do it is like this, minus K. Okay, so I'm going slowly so we can understand. Minus K1 times X1 X, and we can do minus K2, open the bracket, X1 S plus, because this is minus, we'll put this minus here, it's gonna be plus X2 S, the bracket, minus FV, it is S there, open the brackets, X1 S minus X2 S is equal to 0. Okay. So now we're gonna, is equal to this mass M1 S square M1 S square X1 of S. Okay. So from here now we can be able now to put all the X1 together and the X2 together. So this can be now, let me first extend it so you won't be confused. F minus 1 K1 K1, we have this X1, we have also X1 on K2, we have also X1 on that side, we have X2 that side. So what we can do, we can use this one plus K2, open the bracket, and we put X1 of S, then we can do minus this K2. So we have this one and this one, we can also put them together. Okay, let me just put it this way, K2, 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 X2 of S, and we can also S FV X1 of S minus S FV X2 of S, which is equal to mass 1 S square S. Good. So this one also can now continue here. So let's now try to put all the X1 together. X1, okay. So we're gonna have M1 S square plus FV times S X2 or X1 of we put them on the brackets. So let's put F V S plus the bracket K1 plus K2. Okay, then we can do this one. And do this one here times, open the big brackets, times x 1 s, we close the bracket, then we do minus, so we can take this one and this one also together, minus f v s plus, no, it's going to be plus, I think it's going to be plus can open this bracket, plus K2, and we close the brackets, x2 of s, and everything is equal to 0. Are you guys together? Guys, are we together?
Yes.
Okay.
Mm.
We can move. We're together. We can move. Okay. So now, because we have this, now we can replace the value. But the value of M1 is 1, and F is 3, K2 is 5, K1 is 4. So we can replace them already. So we're gonna have here M is gonna be S square plus this one we say is 3 plus 3s, then plus this is 4 plus 5, it's gonna be 9. Close the brackets. And put this one is x1 of s, and then put plus, this one is 3, it's gonna be 3s plus 5 x2 of s. This is equal to 0. Okay, good. So let's move now. Let's move to, let's call this one equation number 1, because we need it again. Equation number 1. Let's move to the second free body diagram. You can draw it. We have this one, and this is the direction, which is x2 x2 of t. Okay, so we have m mass number 2. Okay, how many? Okay, the place is not good to draw it. Okay, guys, for this one, we can put already the value, so it can help us to redeem time. Or let's just do it the same thing. So it can also help other to understand M2. So when we go back here, how many forces do we have here? We have this force, this one, and that one, and also that one. We have also 3 forces. So this one is easy to write. Is in the right direction. It's F of t. So this is the direction, x2 of t. Okay, so we have this one also is a opposite direction, that opposite direction. But remember, For this one, as we did for the first one, there is the force coming from this x displacement and that displacement. So because we only need for the mass 2, we're gonna subtract the force that coming from the displacement of the mass 1. So here we're gonna have K2, gonna use X2 T. Oh, no, not enough space. Let me try to see if I can write it a little bit. Let's reduce the script so we can have, let's put it K2. Okay, let me do this. Okay, this is gonna be better. I have K2, when I write X2 S minus X1 S in the brackets, and this is gonna be FV. You're gonna have G X2 S over dt minus G X1 T over dt. Okay, so this is our three forces here. So having our three forces here, we can now be able to write our equations for the second mass or free body diagram. So let's write this one gonna be minus K2, open the bracket, X1 of T minus X2 of T. No, this is X2, and so this is X2, this is X1, and they are gonna be plus. Okay. Then minus FV. Let's do this. Open the bracket. Oh, sorry for that. Let's use the as we did for the first one, so we can avoid this step here. Let's write the free body diagram in a frequency domain on that side. It's gonna allow us to move fast. M1, 2. Okay. So we have here, it's gonna be F of S, and this side here, it's gonna be K2 X2 S minus X1 S. We can open the bracket here. Okay, good. So for this second one also, we're gonna have something like okay, we're gonna have this one as a bracket here. Okay, 2. Okay. For this second one, we're gonna have also F V S there. Gonna be times X2 of T minus X1 S. This S, okay. And there is 2 down there. Okay. So we have our three forces. We can write now the equation. It's gonna be minus k x2 s plus x1 s, close the brackets, minus fv, there is s there, and open x2 s minus x1 s. So when we close this bracket here, close this bracket, and then we can do, there's another one, plus f s is equal to m the mass, m2 s square x2 s. Okay, so now we can put all the x1 together and the x2 together. So this gonna be, now we have this one, this x2, and we have also that one. So we can put them. It's gonna be the mass. Let's replace straight the value. The mass is 2, so this remain 5 and 3. Okay, so let's put now, then gonna be the mass gonna be 2 s square in the bracket plus this one is only this, so it's gonna be f, it's gonna be 3 gonna be 3s 3s plus k2 is 5 I think it's 5. Close the bracket, x2 of s, then we can do plus, we have this one there, and this one and that one there, so we're gonna have here, gonna have fv s plus that k2 is, we are replacing already the values, so let's put the value there. So it's gonna be now, what's gonna be 3s plus 5, and we close, we have x2 x1, which is x1 of s is equal to f of s. Okay, guys, we can call this one equation number 2. So we can take the equation number 1 and the equation number 2. So we can now solve our system. So we have written our 2 equations. So let's now put them together so we can continue solving. So we have equation number 1, it was s square plus 3s plus 9 k x1 s plus.
Sorry, sir.
Yes.
Sorry to disturb you, sir. Before you go any further, I
Yeah.
just want to ask you the both equation. The first step on K2.
Which one?
On the free body diagram, it says K2 bracket x2s minus x1s. But when you use the equation, you say K2 bracket x2s plus x1.
Where is it? Where is it?
Sir?
Okay. Which level?
The first step on equation 2, sir.
This one.
K2, on K2, sir.
Yeah, K2, okay.
Yes. On the
K2.
free body, yes, on the free body diagram, it says K2 bracket X2 S minus X1 S.
Yes.
But when you write on the equation, you say minus K2 X2
Yeah,
S
yeah,
plus
because
X1 S.
when I do K2 times this one, it's gonna be minus, and this one's also gonna be also minus. It's because there's the minus sign there. Do you get it?
Yes, I can see it, sir.
Yeah.
Means you multiply by K2, sir.
I multiply by K2, so this is K2, right?
Yes, which means negative K2 multiplied by X2S and also negative K2 times negative X1. Then you
Yes.
get positive.
Yes. Normally it's like that. Remember, I just told you that I don't put the sign on the free body diagram, but we know that there is. Okay, let me put it like this, so it's gonna be maybe easy for you. Okay, are you happy now?
Yes, I'm happy, sir.
Yeah, you know, even this side, I was supposed to put minus, then to put plus there. Okay, because all the forces are negative. Okay, minus and plus there.
Yes, sir, I understand, sir. But K2, you multiply by K2. Isn't so, sir?
Multiply by K2. What is actually your question?
My question is, K2 is common, right? K2 is common to X2 and X1.
Yes.
So minus K2 multiplied by X2S is equal to minus K2 X2S.
Yes.
Therefore, you also multiply by negative K2 times X1S is equal to positive K2 X1S. So I didn't see that K2 on X1X.
I don't understand what you say. On this level?
Yes, on first step, sir.
This step, okay, this step, okay.
K2 is common, sir.
Yeah,
right?
it's common, right, yeah.
So if I multiply by K2, I should multiply by on X2 and also on X1.
Okay, yeah.
Yes, so if K2 is negative, I supposed to
K2
say
is not,
negative.
no, K2 is not negative. It is the force that is negative, not K2. K2 is positive. It's the force that are acting that become negative. Do you get what?
Okay.
Do you get what I mean, right?
Yes, I get it. Sir.
Yeah, okay. Because if I multiply this one, the multiplication is the force is, but when we consider the direction, so let me show you here. When we are here, you see now. So multiplying this K2, K2 is positive because it's positive. So, but when I take this force here, K2 times X1, it will become negative when I consider the motion. That I say, okay, this has become a negative force because it's not going in the right direction. So you got it?
Yes, I'm hearing you, sir. I'm hearing you, sir.
Yeah. So it's not K2 that is negative. It's the force that is negative. So we have this force here. We have this force here. Let's say, let's consider this one. That's why I didn't want to put sign on those one, because to avoid people to be confused. Okay. So let's say, okay. Remember, let's go back here. Remember when we draw this one. You see, you remember this one? You can see all the forces we are writing on the free body diagram as they are F1, F2, but it's only when we put them in the equation, considering the motion direction, then we say F1 is positive, F2 is negative. You see now?
Yes, I can see it, sir.
Yeah, do you get it? So let's now go back to our problem. So let's say we have this free body diagram. Okay. Okay, let's say we have this. Let me put it back the way I put it before. This one was and this one was okay. So this one is minus, and this one also is. Let me put it as it was before so you can understand it better. So this one is sorry. Okay. So we say this is, put this one also. Okay. We say this is x1, right? X2,
Yes.
x2 s minus x1 s. Okay, good. So what is happening here is this one. Okay, so we have this free body. This you can call it the mass is like that. Okay, so this is F, and this is the force for the springness. So we know that here we have two forces. Because of this situation here, we have these two forces. Okay, we have these two forces. So what is going to happen is, give me a minute. Okay. So are we together? So it means we have this F, here we have two forces. F1, let's call it F1, and also F2. Okay. So F2 is the force that are coming from the first mass. Okay. We have this one. Okay. Let's put this one. Okay. Let's put this. Let's call this one. This one. Let's call this one F2, and this one F1. So this one here, we have this F2 is the force that is normally supposed to be the force acting on these masses, and we have also this F1 is the force that are coming by the fact that this M1 is linked to M2, and it's also under the force of the second displacement. You get it? Okay. So because we are only considering the force acting on mass 2, but in the spring there is not only one force, there is two forces for the mass 1 or mass from the displacement x1 and for the displacement x2. So we need to subtract this force in that one in the total force so we can remain only with F2. Are we together?
Yes, sir, we are together, sir.
Yeah. So now I'm taking this force here, I do minus this one. Okay. This is before I consider the motion direction. Okay. Are we together?
Yes, sir.
Yeah. So it's before I consider this x2. But now when it's about to write the forces in my equation, I will take this force here. Then I say, okay, writing the force, let's call this one is like F1 minus F2, it gives you like F3. Okay. F3. So in my equation, I will write that saying that it's going to be minus F3. Okay. Why I put this minus, this minus is different from that minus. Okay. Are we together?
Yes, sir.
Yeah, are we together? It's different for that minus because this one is coming from the motion direction. Now you understand?
Yes, I understand now.
Okay. So let's now, I cannot see it here. Okay, let's write it in this way now. Okay. So this is equation number 2. This is question number 1. So this one we can also write, say, 3s plus 5. We can call it x1 of s plus, what is it? Is this one plus 2s square plus 3s plus 5 plus 5 x2 s is equal to f s. Okay, so we have these two equations here. So we can now try to solve. The question was g of s is equal to x2 over f s. So we need to find now x2. So as I told you here, we are using Cramer methods. So let's now solve using our Cramer methods. So we know that x2, let's say x2, x2 will be equal to delta x2 delta will be equal to delta x2 s over delta. So we can find it. This is x2s. Okay, so this one can be found like this. So let's now write our delta. Delta, it's gonna be, to take the value of this value and that one, and that one. So we're gonna have s squared plus 3s plus 9. Okay, this is going to be like 3s plus 5, and there we have also 3s plus 5. There we're gonna have 2s squared plus 3s plus 5. Okay, so this is going to be equal to what? Let's try to solve this one here. Maybe long, so we can put it this way here. So it's gonna be this one times this one. It's gonna give us s. Okay, it's gonna give us, let's say, s squared times 2s squared. It's going to give us 2s power 4. S squared times 3s gonna give us plus 3s cube, I think. Then s squared times 5, it's gonna give us plus 5s squared. Let's go 3s times 2s squared, it's gonna give us plus 6s cube. 6s cube. And this one now, 3, it's gonna be 9 plus 9s squared. This one times this one, it's gonna be 15. I think it's 15s, huh? 15s. Then 9 gonna be plus 18s squared plus 27s. Let's move it a bit to this side. Okay. Gonna be plus 45. Okay. Then we can now do this direction. It's gonna be minus 3. Gonna be 9s squared. 3 is gonna be plus 15s. This one's gonna be plus 15s. This one times 5 is gonna be plus 25. Okay, so we can solve this one. S4 we have 1, S3 we have this one, we have this one, so this is gonna give us 9, so we can write S, this is gonna be delta, going to be equal to 2S4. This one we have this one, we have that one, this is another one, no. Gonna be 3 plus 6, gonna be plus 9S cube. S squared we have this one. It's 5s squared plus 9s squared. That gives us plus 5, it's 14s squared plus this. It's gonna be kind of 32. I think, yeah. I think 32s squared. So this is gonna be minus 9. It's gonna go to give be 23. I think 23 plus 23s. We can even do this one, can cancel that one. So we have 5 plus 18, 23s squared. Then we remain with s, this is 30. And this one is how many? We have 27. 27. So how many s we have here? We have this one. We have this 15s. 15s plus 27. It's 42. 42 minus 30, it's gonna be 12, so plus 12s. Then we're gonna have this one 45, this 20 plus 20. So this is delta. So let's find now. Let's find now delta x. So delta x will be, when we go back to the equation, so we're gonna consider delta x2, we're gonna take this for x1 and this one there. So for x1 we'll have let's say what the value of s1 here. Okay, this equation x2. Okay, these two, those two. Okay. Okay, so this is how it's gonna be. Okay. S square plus S square plus what? S square plus S square plus 3S plus 9. Okay, plus 3S plus 9. And there we have S 3S plus 5. Okay, then on the other side we have F. On this one we have 0. And there we have F S. Okay. So let's now try to do this. And this one is going to give B0, and this one is going to be S squared plus 3S plus 9. In the brackets, we find times Fs. So this is going to be now easy for us to find x2. So we can say, okay, x2 of S is going to be equal to S squared plus 3S plus 9, we open the brackets, Fs over 2S4 plus 9S squared plus 23 plus 12 plus 20. Okay, let's go. Okay, so this is 2S4 plus 9S cube plus 23 S, I think S square, let's see, S square, yeah, plus 23S square plus 12S plus 20. Guys, are we together? Guys, are you there?
No.
You are not there. Guys?
Yes, sir.
You are lost?
We are there, sir.
Okay, good.
Yes, they were lost.
Are you lost? From where are you lost?
I'm lost.
Sorry?
It's ahead of me.
Sorry?
In Cremer's Road.
Sorry?
In Cremer's Road.
So do you know Crema's role?
No.
Yeah, you should. Okay, that one you should learn it. But is like what I told you in class, say on this level here, once you have your two equations here, you can use any other method that can solve a system of two equations. What's going to be suitable for you, as long as it's correct, you're going to find the same answer. So we are using Cramer because we think that because we can set in control, we like it because it simplifies things, easy to multiply things, so there's not too much confusion. But you can use any other method. But this is not a big problem if you understand the principles up to those two equations. So it's okay. So what will remain is just to find this x2 over this one. So we know that as we have find this one, now we know that g of s, the transfer function. So in the class note, we use x1 as output, but here I use x2 as output. So we'll have x2 s over f of s. So this is going to be now easy. It's going to be just, let's say, s squared plus 3s plus 9 is equal to 2s4 plus 9s cubed plus, okay, plus 23s squared plus 12s plus 20. Okay, so this is the transfer function. Okay, is there any question? There is any question?
Yes, sir.
Okay, what's the question now?
Say, instead of f of s, why do you put delta?
Delta where?
The 2s4 plus 9s squared plus 9s cubed is for delta. It's not for fs.
This one. I can't hear you. Your network is not good. What were you saying? Sorry. Yeah, come again. Like I could not hear you. Yo. Let's see what is happening here.
For equation 2.
Okay.
I can hear.
Now I think I can hear you. You're saying what?
I was asking if why did you take the number for delta instead of taking the number for f of s, which is on equation 2, which is 3s plus 5 something, this one that you're showing now?
This one.
Yes. Why didn't we take that value? Now we're taking the one for delta, of which we're calculating delta for Cramer's rule.
Your question, why I didn't take this number?
Yes, I'm asking why didn't you take the whole of equation 2? Because it says equation 2 is equal to f of s.
Yes,
right?
yes.
And
Yeah.
then on the equation, g of s is equal to x of 2 is to s all over f of s. But on the answer there, you took, instead of f of s, you took this delta that we were calculating for Cramer's rule.
Yes.
The delta we used to find x2.
Yes. So it doesn't necessarily mean that that this one is equal to this one. No, it doesn't mean that. I think you get it. This is the ratio.
Okay, so we just take the delta of the Cramer's rule, not the.
No, I'm not taking the delta of the Cramer's rule. So what you need to understand, why did I use the delta? That's why I was telling you can use any other method to find this ratio here. Okay, why did I take the delta? Listen. Okay. Do you know how to solve system of equation, right? When we have x and y, okay?
Yes, I
Yeah,
can
so-
even understand Kramer's rule, but
It's okay.
what I do,
That's what I wanted to try to explain to you. Okay, so what we are trying to solve is to get the ratio of the output over the input. We are not trying to say down to this. So we know that the input is f of s, right? Okay, and this is the output. We choose this particular output. So we are getting the equation of the input and the output in the system. But this one, when we consider this particular system, so this includes a system of two equations. Are we together? Where we have x2 and x1 as output, but we choose only one output. Are we together? So we must make sure that by choosing only one output, we don't have x2 or with x1. When x2 is output, we are not supposed to have the other output in the equation.
Oh, I see now, sir, I see.
Yeah, oh, you see it, huh? Okay, thank you. Okay, so another question? Okay.
No question.
Okay, I think we are done by here because it's already 23. So I was expecting to do more exercises, but time it's okay. But so probably as we are writing next week, as